one. Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Ali, who has completed one of our courses, ROS 2 Basics. And at the end of this course, there is a final project that you are supposed to complete and test on a real robot in order to get a certificate of learning. So that is what we're going to be seeing today, Ali's project. So hello, Ali, how are you?
Hello, Rodrigo. How are you? Thank you.
I am
That's
I
very
am
interesting.
well as well. Thank you. So whenever you want, you can start sharing your screen and show us how you've done your project.
Sir, uh, hi everybody. I'm Ali Jafari Fesharaki. You can connect with me with LinkedIn, GitHub, and ResearchGate on YouTube. In this course, Rust Python course, we learn a lot of amazing things. As before, like C++ course, we first learn about packages and nodes in Rust. After that, we learn how to create a publisher subscriber in object-oriented way that is very efficient and very good way for developing Rust software. And after that, we introduced the callbacks and multi-threading when we want to use simultaneously publisher software services and together. So, and after that, we learned the service, how to use custom service and how to use in next step, we learn action server and client server and custom messages and custom actions. At the end, we learned debugging tool ROS and something Dr. ROS that is useful for checking your packages. For the first step, when we actually we had some problems when we want to move from simulations in the course to Rust-Check, but it was okay.
Right.
For example, some assembly, something mounting about LiDAR mounting on the robot and something like that, and some simulation difference. And in the end, the challenges that we had from Rust-Check to the real robot, when we had that was some again some problem, not problem. They are very common that you had a different actually LiDAR for one robot, and when you move to another robot, it's different and has a different resolution. Okay, without any can you see my screen?
Yes, we can see
Yes,
the
this is the
robot.
real robot map. You can see that as the task wanted us, we prepare one launch file to move this robot while following the robot. And after that, it records the odometry points during this journey. And when it passes one loop, it can guess it and it can find that it passed it and it stops again. Now we can see the performance of the while following. Excuse me. Actually, I use this launch point both for real robot and simulation.
Mm-hmm.
So we should add extra things that this
Oh,
is
love
real.
that. Love it. Love it.
Yeah.
Nice argument passing there. Oh, wow. That was a hard maneuver.
Wow. That's a. No. Excuse me.
Don't
That's
worry.
a yeah. It's a little challenge that it speaks on that that point because this robot doesn't pay attention to the obstacles. It has
Ah,
some problems. But
I see.
something in the next challenge, in next forward challenges, we had this problem in. Okay, I'm so sorry for that, but
Oh no, don't worry. Don't worry.
yeah. Oh,
Maybe you
it's
have to start it
yeah,
far
yeah,
away from the obstacle then.
yeah,
If
because
it
I think that it's okay. Maybe it found this. I'm sorry. Yeah, this
Oh,
is the
there you
service
go.
for find wall. Again, it does it. You know, it's because I passed angular velocity. Maybe it's a little. Uh, um, it has it needs fine tuning. You know,
Right,
uh,
right. I
but
see what
I
you're
think
saying.
yeah,
That's nice.
but it works. You know, for a little challenge. You
S-
can see the action server pass the feedback,
Mm-hmm.
and when it passes one loop, and in the middle it decay to the wall, and you can see this is the actually I say that when it starts and past one loop and it's near to the start point from 30 centimeter, you know, it's not exactly the same position, but my end goal was 30 centimeters
Around.
circle around that, yeah.
Okay.
And because it stops, now you can see the odometry, the positions that it passes. Uh,
So
you
that's the
can
whole
see,
list of the points of where the
yeah,
robot passed
yeah.
through. All right.
If I want to explain a little code about you, I made three nodes. One wall following node, another one find wall node
Uh-huh.
that brings up the service of find wall node that you can you saw that I approached the obstacle first because it was the more
It was
near
closer.
than
Yeah.
more close than actually the wall. And this service has some challenges because it needs a publisher, it needs a subscriber, and it needs server. So I make some separate nodes because paralleling and it's more efficient to do it in parallel. For example, it um, we have a rangefinder that class that takes the uh, actually the scans
Mm-hmm.
subscribe on a scan uh, topic, and after that I pass it to as a you can see that I added every node to the executor and make it live. And you can see that I pass it the rangefinder and command publisher, the findwall class as a object. Their object is it's the benefits of using actually object-oriented programming. It's very
Mm-hmm.
efficient. And in ODOM record node, again, we should something to ODOM reader, and we should something to ODOM record server. I use two nodes, and again, I pass the ODOM reader to the
Nice.
ODOM record server. And the last one, wall following, which as again two separate nodes, ODOM record client, and in here I set the condition of the starting and ending the position, ending the loop.
Hmm.
When you start the robot, it has a problem. This problem that when you pass it, it's in circle that 30 centimeters from the start point, so it can break it suddenly and don't go one loop and doesn't go one loop or one loop. So I use the distance passing for condition in the server to see that. And when you can see that odem record node in here, yeah. I this You can see this actually condition when the condition is true, it passes the result. So when it passes the result, odem record client get the found that one loop is passed, and it says that the robot should stop with the one flag. We have a global flag. I can use it as a passing object, but I didn't do that. I prefer to use it a global variable. Is it okay?
Great. Yes. Yes. You basically covered all three sections. Congratulations, Ali. Really nice project. Do you mind stopping sharing your screen so we can talk here face to face? Great.
Yeah.
Awesome. Great. Really nice project. I have a bunch of questions for you, Ali, that I think are interesting. First of all, I think it was interesting how you actually spin up multiple nodes from each section, right? So I saw that was nice that you created a class for the odometry server, and then for the client, and then for the LiDAR rangefinder, and then you spin like three nodes in the wall follower node. That's nice. I mean, it's a different approach than just launching everything in one node. It's interesting. That means, and then the one question I do have is based on the behavior we saw, right? Mm-hmm. So if I understood you correctly, you said we saw in the beginning how you launched your program, and it looked like it found the wall. At least it seemed like it. It found the wall and it went towards it. And in my understanding, at that point, the service is completed. And then we saw the robot move towards the obstacle. So why do you think that is? Because I'm not clear on how it would be about the service if the service is completed at that point. So why do you think that behavior occurred?
Mm-hmm. As I find out your question right, you mean when the server when you find actually first I find the wall and it sticks on that line, yeah, and I make some you can do it in both process, that you can make a flag to stop that process. If you want to, if you run the server service client in the asynchronous, I think mode, that it's allowed to other threads to continue to their live. Actually, you can use that, but I use that. It sticks on the that program and first find the wall. And when the service is okay, give the feedback and complete the service, it goes to the next part and creates
the wall following node.
Creates the publisher and something other things. I think I did that in like.
So the point so at the point that where we saw the robot go into the obstacle and crash, was that service completed yet? Or it was completed?
Service, it was completed.
Yes, it makes sense because then the second part something that the second part where it went and did the loop, right? In the first wall, I noticed it got a little bit too far away from the wall on that section. So I was also wondering, it makes no I didn't think it was because of the service. So maybe it's a condition. So I was wondering, what condition do you have set for the wall to sort of come back to it when it's too far away? Because at that point, I think it was a little too far away.
Oh, okay.
But then it kind of fixed itself.
Yeah, but it's not very very high condition. You know, the movement towards the wall is very little, and it's not very intense. So because of that, it can't go toward the wall and couldn't go. Because
so you run that risk.
Yeah, because when I set the intensity of charging the wall very high, it goes directly
towards the wall.
Yeah. So I should set the arc, the radius of curving the robot more than the length of the field. You know what I mean? If you do it under the length of the wheel, it's make it a very little circle and towards the wall. So I put it the very not intensity on angular velocity when I set that towards the wall.
Yeah. Okay, I see what you're saying. I understand. Great. So then I guess my last question would be, so for the people that don't know, Ali here has done the 2 ROS Basics courses in C++ and in Python. I guess my question is, which one do you prefer to use and why?
Actually, C++. Actually, it has it doesn't have. I don't know. Actually, people know about the composing components or not?
Composable nodes? We have.
We have it in C++, and in Python we don't have it actually.
Right.
And in handling the thread, in handling the lifecycle nodes or something like that, and the actually the hertz of the node, it's the C++ is more efficient. And just it has some problem with the coding, But Python, you don't have any access very deeply in the robot, and it's not good for implementation, and it's not efficient. I think Python is more more usable for plotting, very fast developing, and just for typing. It's not for implementing. It's not for if you learn C++, you love it.
I agree. I'm happy about your answer because I completely agree. And sometimes we like to take the easier route, like you said, for developing and doing quick things. So a lot of times in robotics companies, there are huge projects of migrating their code from Python to C++ because they want to make it quicker. They want to make it more efficient. They want to be able to manage the things you mentioned with the threads and all that. Of course, there's a reason for this, and for most people, that is because Python is just a little easier to handle. But if you are already preferring C++, then you're going to love ROS because it will just go way better with C++. And some other things, maybe not anymore, but ROS 2 was fairly recent. So for example, for very popular packages, for example, there's one called MoveIt2, which is used for robot manipulators. They, for the longest time, maybe it changed. I think it might have, but I'm not completely sure. There's only an API for that great package in C++. So if you wanted to make something, in Python, you would have had a lot of trouble. So might as well switch to C++. And I'm sure there's a bunch of other examples like that. So I'm happy and interested to hear that. And I just want you to continue on that path. And I guess that's it. That's all my questions. I want to congratulate you again, Ali, for a successful second project here.
If I want to add one note about the C++, the control engineers, the control researchers, the robotics researchers who are not familiar with the actual C++, and they just knows about how to optimize the optimization algorithm, reinforcement learning, or something like that. They prefer to use Python because it takes a long time to approach to C++. So they don't prefer that. And but when you are a researcher, in your real researcher, or you are a real robotics engineer, you should know about C++.
Absolutely.
And you should know how to convert Python to C++.
Absolutely.
Thank you for your consideration.
Well, thank you, Ali, again for your project. So congratulations. Let me get here going a little. Congratulations. So yes, basically that is it for us, guys. So let me switch my screen here. So yes, great job from Ali. So whoever's watching, this is your opportunity to do the same as Ali and complete your projects at the end of your courses here at the Construct on a real robot. And that way you can show everyone what you've taken away from our courses and, of course, obtain a certificate from us. So that's it for us, guys. So thank you very much for watching and keep pushing your ROS learning. All right. Bye-bye, guys. All right. First one.